Okay, so let's go and take a look at these problems here. We're going to go from mass to moles and moles to mass. So the first thing that we have to do, we're starting with moles and we're asked to find grams. So in this problem, we're starting with moles and we're going to grams. So moles to grams, we're going to use the molar mass. So we're going to follow this path. So we need to find what the molar mass is first. All right, so if we have BeI2, so our molar mass is going to be the Be on 1Be, 2 I's, so 1 and 2. Then we're going to multiply this by the mass of each of them. So if we look up beryllium, beryllium is 9.01. And if we look up iodine, iodine is going to be 126.90. So we add these up, we're going to get 9.01, 126.090. And then we add these together, so we should get a total 135.91 grams per mole. All right, so then when we're filling this in, we're going to make our T-table. Start with moles. We're going to put at the top, so 0.02 moles. And then we look at our map. If we're going from moles to grams, we're going to put the molar mass on top over 1 mole. So the blank spot's for the mass. So we have the mass of 135.91 grams for every 1 mole. So moles and moles cancel, and then we multiply this out to get our answer. So 0.02 times 135.91, we'll get our answer of 2.7, round this up to 2. All right, that's the first one. Okay, second one, we're going to go from grams to moles. So we're going to start with grams, and we're going to ask to find moles. So going from grams to moles, we're doing the opposite. Grams to moles, we follow this. We must use the molar mass. So it's 1 mole on top, grams on the bottom. So let's find the molar mass of this. We have copper, so we have 1 copper here. The 2 is going to multiply everything inside, so oxygen, we have 2, hydrogen, we have 2. And then we look at copper. Copper is going to be, so oxygen's 16, hydrogen's 1.01, and copper is 63.55. So if we add these up, we get 63.55 plus 32 plus 2.02. So we add these, we get 7.5, that's 579, so 97.57 grams per mole. So let's fill this in. We know that we're going to take the 68 grams of copper and put this in the top. And then we have the mass here. So 97.57 grams for every 1 mole. So we know this for 2 reasons. The grams and grams cancel out. We could also see if we're going from grams to moles. We're starting with grams, we're going to moles. Grams to moles, we must use the molar mass. 1 mole is on the top, 1 mole is on the top. The molar mass in grams, molar mass in grams. All right, so we multiply the top, we divide by the bottom. So this should be 68 divided by the number on the bottom. So we're going to get 0.696. This rounds up to 0.70 grams. Moles. Answer is going to be moles. All right, and then it's more of the same. So let's look at the problem for the next one. Here we're given moles and we're asked to find grams. So this is going to be like the first one. Here we have moles to grams. Here we have moles to grams. So if we're going moles to grams, start at moles, go to grams. We're going to put the molar mass on the top, 1 mole on the bottom. All right, so let's do this. We have K, we have S, we have 2 Ks, we have 1 S. Sulfur is 32.07. Potassium is 39.10. So this should be, we put this in our calculator, 39.10 times 2 plus the 32.07. We'll get 110.27. All right, so we're going to plug in what we're given, 3.3 moles. And then we look at our mole amount. So if we're going from moles to grams, we start at moles, we go to grams, follow the arrow. 1 mole goes on the bottom, the grams go on top. So 1 mole goes on the bottom, and the grams, this is grams per mole. We get 110.27 grams every 1 mole. All right, these cross out. So then we multiply it out. We have our number here. We're going to multiply this by 3. So we should get 330.81 grams. All right, let's look at the last one here. We'll have you try the last 2 by yourself, but let's look at this one here. We're asked to find moles. We're given grams. So in this problem, we have 1.2 times 10 to the 3rd grams. We want to find our molar mass of ammonia. So ammonia, we have NH3. N is going to be 14.01. We only have 1 of these. We have 3 H's times 1.01. So this will give us 3.03. So when we add these together, 17.04 grams per mole. So again, look at this. We have grams here. We want grams on the bottom. So they cancel. We have mole on the top. So grams on the bottom, mole on the top. We have grams here. Another way to look at this, if we're going from grams to moles, follow your arrow. 1 mole on top, grams on the bottom. And then we have the 17.04 grams. All right. And that would be our answer. We just multiply this out. 1.2 times 10 to the 23rd power times 10 to the 3rd power. So 1.2 times 10 to the 3rd power divided by 17.04. And we're going to get our answer 70.42. Answer in moles. Okay. We might as well continue going through the rest of these. All right, so for the molar mass, I'm going to write this down here. We have Ca, we have P, we have O. So calcium, first one, we have 3 calcium, so the 3 put here. Phosphorus, we have 2 times the 1 here. So we have 2 phosphorus, 2 times the 3 here, we have 6 oxygen. All right, and then let's look up our masses. For calcium, it's going to be 40.08. Phosphorus is going to be 30.97. And oxygen 16. So then we can just multiply these out. So 3 times 40.08, 120.24, 2 times 30.97, it's 61.94, and 6 times 16, we're at 96.00. So then we just add these together, plus the 61.94, plus the 120.24, 2.24. So she got a total of 278.18 grams per mole. And then that's what we're going to fill in. So let's look at what we have here. We have 2.3 times 10 to the negative 4 moles. So to solve for this one, we have moles here. We want moles on the bottom. We're going from moles to grams. So moles to grams, we use the molar mass on top, 1 mole on the bottom. So 1 mole on top. Oh, already had it. So we have 1 mole on top, and then our mass, 278.18 grams on top. Moles will cancel out, so then we just multiply this out. So 2.3 times 10 to the 4th power negative times 278.18. So we're going to get a total of 0.64 grams. All right, let's look at the last one here. We're starting with grams and we're going to moles. So we're trying to find moles. We're given grams. So we have 3.4 times 10 to the negative 7 grams. We have silicon dioxide, so SiO2, 2 O's, 1 Si. So silicon's 28 point something, 28.09, O is 16. So times 28.09 times 16, 32. So we get 900 at the 1, so 60.09 grams per mole. So 60.09 grams for every 1 mole. We know that this cancels out, or we could look at our math. If we're going from grams to moles, we're going to use 1 mole over the mass. 1 mole over the mass. So then we divide 3.4 to the negative 7 power. So 3.4 to the negative 7 power, so 7 negative. And then we're going to divide this by 60.09. And we're going to get something really small. Let's go total 1, 2, 3, 4, 5, 6, 7, 8 zeros. And that's our answer. Okay.